Okay, in this last part of this example, we're going to be sneaky. The sneaky part is that we're actually going to introduce equilibrium, all in the context really of just working with vector components. Right, so we had started a problem off that had three forces applied to it, focused only on these two, found a resultant from them. We've now added a third one. I'll let you go work with what those x and y components are. Here's the answer for that third one. And we're going to ask the question of, okay, let's add a fourth force to all of this so that when we do sum up all of these, we end up with then 0. In other words, it turns out that that would be a statement of equilibrium, that there is no net force effect on the system. Right? Now, theoretically or technically, you don't know what equilibrium is yet, even though you really do. But we'll pretend like you don't. Now, when we do this, what we're going to end up with in a nice, beautiful fashion, we need to have an x and a y component. We need two equations, and here they are. That when we sum up all of the x components, that is, sum up all of those, that has to be equal to 0. That's a scalar equation. And the same thing then will be true about all of, including the signs, all of the y components. So the one vector equation is that the sum of all forces must be equal to 0 in vector space. In scalar space, and that's just one equation in vector space. In equation space, we just end up with two scalar equations. We just sum these up, so that means that f for x would be equal to the opposite of the sum of the others from 1 to 3, which would be the opposite of 424.26 minus 692.82 minus then the 434.67. So let's see what that looks like. The inside the brackets part would be 424.26 692.82 minus 434.67, which is the net of minus 703.23, but then we add, or we hit that with the additional minus sign, so we end up with positive 703.23 needs to be added to the system. We're in units, of course. And when we do the y's for the fourth, we'll end up that is the opposite of 424.26 plus the 400 and minus 116.47, and that will turn out to be then a minus 707.79 newtons. Okay, so our fourth force then will be 703.23 newtons I minus 707.79 newtons J. I don't really like working with that very much, so let's go find out what that magnitude is. Square root of the sum of the squares, hypotenuse of a right triangle that has been formed by these two orthogonal components, and that magnitude will be about 997.7, which we will get to the right significant digits here in just a second. And let's see, it has a positive x direction and negative y direction, so it's sitting in the quadrant that is down here, where the x is 703 and the y is 707. So I want this angle right there, call that alpha. Tangent of alpha is opposite over adjacent, so 707.79 over 703.23. That's inverse tangent, therefore alpha equals 45.2 degrees. So my answer that I prefer to work with here is the polar form of F4, that it equals 998 newtons acting clockwise from the positive x-axis at 45.2 degrees. Nothing starts with a 1, so we use 3 significant digits in our answer. And let's emphasize where our answer is and bubble that thing. Boom.